Hello everyone, so I'm starting with a very small and simple optimization problem, and in later videos we'll see we'll solve some complex optimization problems. So here the first problem is we have a situation here. Let's say we call it YARA chemicals. So they manufacture specialty chemicals or fuel, something like that, and one of their product comes in two grades, high and premium. So two grades, and the capacity of the plant is limited at 110 barrels per week. The high and the premium grade products basically use the same raw materials but require different ratio of additives. The high grade requires 3 gallons of additive A and 1 gallon of additive B. The premium grade requires 2 gallons of additive A and 3 gallons of additive B. Okay, and the supply of both these additives are quite limited, and each week the product line is allocated with only 300 gallons of additive A and 280 gallons of additive B. And the barrel of high grade has a profit margin of USD 80 per barrel, and premium grade has a profit margin of 200 per barrel, USD 200 per barrel. And so now what we have to do is we have to find out how many barrels of high and premium grade should your chemicals produce each week to maximize its profit. So in any optimization problem, we will have to look into three things. One is we have to determine the decision variables. That is, what are we trying to decide, or what are our upper or lower bounds. Second one is to formulate our objective functions. So what are we trying to minimize or maximize? And we have to remember that the objective function must include decision variables. The third thing is that we have to formulate constraints. So what is my feasible region for my solution? What are my limits? Okay, so must include the decision variable and will almost always be linear functions. So these are the three steps for any optimization problem solution. And we will try to do the same, we'll try to apply the same for the YARA chemical problem. So here first we determine our decision variables. We call it XH, the number of high grade barrels to produce, and XP, the number of premium grade barrels to produce per week. And here is our limit. So we are saying that okay, we produce 0 or more. For both of them we produce 0 or more. We cannot produce in negative numbers. Step 2 is to formulate the objective function. So here our objective function is profit. And if you remember, we have 80 USD profit margin for one high barrel cells and 200 USD profit for one premium barrel cells. So that's why we multiply 80 with XH. So XH is the number of premium that we will produce, and plus 200 multiplied with XP. XP is the number of premium grade that we'll produce. So we can represent it as like maximize Z x comma xp equal to 80, in this format. 80 multiplied with xh plus 200 multiplied with xp. So now the third step in optimization problem is to formulate constraints. So here, if you remember, our first constraint is that we cannot produce more than 110. Okay, so that's our first constraint. So xh plus xp, the total number we will produce, should be less than or equal to 110 barrels. And if you remember, we have some constraint for our additives. So our high grade requires 3 unit of additive A, and also high grade requires 1 unit of additive B. Okay, so this line here is for additive A, and this line here is for additive B. Okay, and our premium grade requires 2 units of additive A and 3 units of additive B. And these are all limits. So 300 is the limit of additive A. So that's our limit. So we cannot use more than 300 unit. That's why we're using less than equal to. And we cannot use more than 280 of additive B. So that's why we're using less than equal to 280. So the full problem looks like this. Objective function, and then our objective is subject to these three constraints and some other constraint that it has to be positive numbers. So that's what we will solve. Now let me show you how to solve it in Excel. So in this Excel file, you see we set it up the information that we have. Okay, so for high barrel, 3 units of additive A, 1 unit of additive B. For premium barrel, we need for premium fuel we need 2 units of additive A, 3 units of additive B. And for additives A we have a capacity of 300. For additive B we have a capacity of 280. Okay. And our profit per barrel of high that we will sell is 80, and premium we will sell is 20. So that's our profit, and total plant output capacity is 110. So now we here fuel to make is our decision variable. So how many high we will produce and how many premium we will produce. That's our decision variable. So in the beginning for decision variables I actually like to start with 0. So I just put 0. These are the numbers that we will get from the optimization after based on the solution of the optimization. But as a starting point, we can put it to 0. And here total profit. So here I can use a function. I define my objective function. So equal to. So my profit is the number of high grade fuel I will sell multiplied with the profit of that plus the number of premium grade fuel, premium grade barrels I will sell multiplied with its profit margin. That's my objective. Okay, so that's what we will get here. Here we will define the additives, how much we have used, so that we can use this cell in the constraints to define the constraints. So used additives, how much is that? So I start again with the function here. So for each unit of high we produce, we will need 3 units of additive A, right? Plus for each unit of premium we produce, we will need 2 units of additive A, right? So we define it like that. Then again here for additive B, for each unit of high grade we produce, we need 1 unit of additive B, plus for each unit of premium grade we will produce, we will need 3 units of additive B, right? And fuel to make, the total barrels we will make is just the sum of this plus these two. Okay, so that's how we set our Excel file. Now we will go for the optimization. We go to data and so now here I am in my Excel solver. So what I'm trying to do is I'm trying to maximize my profit. So I'll select here, set objective is this cell here, right? So this one I will say maximize by changing cells, my decision variables. We always have to put the decision variables in changing cells. And here we have to add the constraint. So normally I first think about capacity constraints. So for instance, the total fuel we will produce should be less than or equal to our total capacity, which is here, right? And then the additive used of A should be less than or equal to the capacity of additive A, right? And the use of additive B, total use of additive B should be less than or equal to the capacity of additive B. So we also add that. And let's say we will produce in full units, 1 barrel or something like that, full units, so we call it integer. And let's say we also say that these values are always positive. Okay, so we will not produce any negative amount of fuel. We will only produce in positive values. So we say greater than or equal to 0. So it can be 0 or higher, but not negative values. And then okay. So this is how our simple optimization definition optimization settings look like. So we have the constraints, and these are decision variables, and this is my objective function. And here we have few options, but I will use the simplex linear programming, and then I solve, and we get a solution which is 19,000, and this is actually the correct answer. So that's how we can solve this problem. Okay.